Hi there, my name is Issack Vaid, and today I wanted to talk to you about inheritance. What is inheritance? Allow me to ask you a question. You hear someone say he has his father's eyes or she has her father's look. Now, is that some sort of big belief, or is there something truly there on a biological level? Did we just grow up believing that, yes, we look like our parents, and so therefore we inherited our physical traits from them? Or is there something truly to it? Now, what if my whole life I grew up believing that I am the son of Dwayne "The Rock" Johnson? Now, if I sort of did a smolder, I think you could see the resemblance. Huh? Perhaps not. Now, there is something there when it comes to inheritance, and there's a lot to it. But first, before we go into it, let me introduce you to someone very, very famous, someone very well known in the realm of inheritance and genetics. That goes by the name of Gregor Mendel. Now, Gregor Mendel is a scientist. He is the founder of genetics. If it weren't for him, we wouldn't have the fundamental laws of genetics and what we know about it today. Now, alleles. An allele is a variant form of a given gene, meaning it is one of two or more versions of a known mutation at the same place on a chromosome. A better way to get to know this is an allele is a pair that's part of, when paired together, it becomes what we call a genotype. A genotype is, by definition, the genetic constitution of an individual organism. Now, a genotype, in essence, is the genetic code, the makeup of our physical traits. Now, along with the genotype, we have what's known as a phenotype. Now, a phenotype, by definition, is the set of observable characteristics of an individual resulting from the interaction of its genotype with the environment. Let's make that a little more clear. A phenotype is what you see. You see me, I have dark brown eyes. Now, you most likely have dark brown eyes, or perhaps hazel or blue or any other color of the spectrum. Now, what I see there is your phenotype. It's clear and given. However, the genetic code behind that phenotype, what we call the genotype, could be different, or it could be the same. It could tell us you were 100% most likely to have this phenotype, or you were, let's say, 25% likely to have that phenotype, and we don't know. And the way we can observe that is through what's called a Punnett square. A Punnett square is a square diagram that is composed of a grid of usually 4 boxes and is used to calculate and depict all the combinations of frequencies of the different genotypes and phenotypes among the offspring of a cross in accordance with Mendelian inheritance. Now, what is Mendelian inheritance? That is the inheritance of characters specifically transmitted by genes in accord with Mendel's law. We learned about Mendel, Gregor Mendel, who was the well-known scientist known as the father of genetics. I wanted to go over how you can create a Punnett square yourself. Sharpie, paper. The way I like to do it, create sort of like a tic-tac-toe, and then I like to just connect the bottoms there. And then you just label the top, mother, father, doesn't matter, and then the opposite on the other side. I've already done that for you, because we're gonna go over 2 examples. First one, let's say my mother has blue eyes. Now, typically the genetic code for blue eyes are recessive, so I'll put that down, R and R. And let's say my father in this example has brown eyes, but they're both dominant alleles. So we'll put, it doesn't matter the letter, let's just do 2 capital B's. When you connect them, sort of just BR, 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 BR. They're all the same code, which means I was 100% likely in this scenario to have brown eyes. Now, in this example, same example, my mother has 2 recessive alleles for her blue eyes. My father, he does not have 2 dominant alleles for brown eyes. He has 1 dominant allele, and he also has, let's say, a recessive allele. Sort of like, again, something you can't really see. You'd have to get genetic testing done in order to see what it actually is. But let's just sort of play around with it. When you connect them here, see BR, BR, and then this would be R, 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 R. You could see here that I was 50% likely to have brown eyes in this example. And I was also 50% likely to have blue eyes in this example. So it would have been 50 and 50, which is pretty cool. Now, that said, that's really all there is to inheritance. And I'm glad that you're watching. Also, remember that all genotype is beautiful. So be proud of yourself. Love yourself for who you are. It's a miracle that we're all here today. Thank you so much for watching. My name is Issack Vaid.